Welcome back. We're going to solve another trig equation in this video. We're going to need to determine what the variable alpha could be, and we're only going to find the solutions in one rotation of the unit circle. So from 0 inclusive, leaving out 2 pi. So what we have here is 2 tangent alpha times sine of alpha equals 2 tangent alpha. Okay, so solving this equation, a lot of you might say, oh, I can divide by 2 on both sides, and that's fine, completely acceptable to do. That leaves me with tangent alpha times sine of alpha equals tangent alpha. However, if you felt inclined to divide by tangent alpha, that would be wrong. And the reason I have to ask you, what is tangent alpha equal to? Is it possible that I can get some output value of 0 for tangent alpha? And the answer is yes. We don't know what alpha is, so we have to assume it could be 0. And are we allowed to divide by 0? No, this would be an illegal action. So what I'm going to do is I'm going to bring both terms onto the same side of the equation and set it equal to 0. At this point, I can see I have a GCF, and I'm going to factor that GCF. I'm not going to divide by tangent alpha and cancel it out, because that's going to potentially cancel out some of my answers. So if I factor my GCF, that leaves me with tangent alpha equals sine alpha minus 1 equal to 0. From here, we say, well, tangent alpha equals 0 or sine of alpha minus 1 equals 0. So once I have two factors equal to 0, I know that each of those two factors can be set equal to 0 by my zero product principle. So I have two basic equations to solve. Where is tangent alpha equal to 0? So if we come over here and think about our unit circle, that's messy, let's make that look better. Because we're dealing with 0 or 1, I know I'm going to be on these quadrantal angles. So let's go ahead and list them and write our ordered pairs. We've got 1, 0, we have pi over 2, 0, 1, I have pi, we have negative 1, 0, and at 3 pi over 2, we have 0, negative 1. Remember, tangent is sine over cosine, or y over x. So at pi over 2 and at 3 pi over 2, tangent is undefined. But at 0 and pi, tangent is equal to 0. So for this alpha, we know we're going to be getting pi and 0. So we have that alpha equals pi or 0. For my other equation, that would be sine alpha is equal to positive 1. Where is sine of alpha equal to positive 1? My y value is equal to positive 1 at pi over 2. So we'll include in here pi over 2. And that's the only spot. So we have 3 solutions. We're done. We're not done. So in the last video, I mentioned that certain trig functions have undefined values in their domain. And even when I was working this out a minute ago, I said tangent of pi over 2 is undefined. 1 over 0 can't divide by 0. So pi over 2 is extraneous. The only solutions we get that work here are pi and 0. And even if we came up here, as soon as you see that tangent, or you see a secant, a cosecant, or a cotangent, you know you might have to consider the fact that there could be an extraneous solution. And again, if you wanted to check these answers, which I encourage you do, you could say tangent, or I'm sorry, 2 tangent pi Sine of pi minus 2 tangent pi. Check that equal to 0. 2 tangent 0 times sine of 0 minus 2 tangent 0 equals 0. And if you check pi over 2, you'll get an untrue statement. So I hope that helps. I'm going to do 2 more examples in the 2 videos following this. Email me if you have questions.